Okay, so this is going to be the kind of RasAero tutorial. Here we have rocket or 10K rocket. So to start every trajectory analysis, you want to make sure all the code is up to date, or not the CAD, sorry, is up to date. And we usually have for each rocket a spreadsheet that has all our aero info. So in this scenario, I'm not like sizing fins or sizing motor or anything. This is assuming you have all the information. Let's figure out how high it goes and how fast it goes.
Okay.
So this spreadsheet has all the parameters basically as you see them in RasAero in inches, and then it converts it to meters. So if you're all ready, I'll switch to the RasAero. So this is kind of what you see. So when you first open up a new file, the only thing you can add is a nose cone. And this dialog will pop up. Okay, so if we look, we have an 18-inch long nose cone, 4.66 diameter, and it's an elliptical shape. So elliptical. These are kind of funny to enter. 18 inches long and 4.66. Oh, I got these backwards. Sorry. 4.66 inches in diameter. And so that's the base diameter, which is the same as the rocket diameter. 18
Right.
inches.
Okay. Okay.
There's no tip radius. So now it's printed out your nose cone here. So now you have a nose cone. You can add either a body tube or a boat tail, but you got to kind of add them in order. So we're going to add the body tube. The length, according to this, is 96.84 inches.
Can I ask a question?
Okay, go ahead.
Okay, so why is it that we have the software? Well, obviously the software is in inches, but why do we have the metric in the Excel?
It's just good for like context. There's other software that we used to use that does use metric.
Oh, okay.
But
Okay.
generally, like most or a lot of engineering things like manufacturing is in imperial because you buy like imperial stock. Like if you want to make a plate, buy like 4-inch diameter and
right, 3/4 inch thick, this kind of thing. Okay. Okay. Just checking.
yeah, no, really good question. So on the body tube, there's all kinds of stuff. So you can add, I haven't really messed around with these, but you can add like launch, which are the kind of, they're like these rings on the outside that like guide the rocket, kind of rail guide. Yeah, again, I don't play with these much because they're a little unclear about like what they actually do. So
Okay.
there's also this protuberances, which kind of model like so the fins, they don't sit like perfectly on the rocket. There's like the fin foot. You can like model stuff like that or like external antenna. This is the same thing. There's not a ton of information on it, so I don't typically use it.
Okay.
But so if you want to add fins, you have to add them to a body tube. So to add fins, you click on the fins dialog. So you'll see here, I'll take a screen grab of the fins so that we have this. Goes away. So as you can see, they're just entered as they are in the spreadsheet. So root core is 10 inches. So that's this bottom length. Span 4.25 inches. That's from the bottom to the tip. Tip chord is 3.5 inches. So that's this length here. The sweep distance is 6.5, which is the distance from here to here, like that vertical distance, basically how far that sweep is. Okay. And it's 0.12 inches thick. And so distance from the base of the tube. So hopefully you guys can see these are all just what we have.
Mhm.
Specified distance. Okay, we don't have it worded exactly the same, but distance from the base of the tube is from the tip to the base of the tube. And so there's this 1/8 inch gap. So this number is the root chord plus that gap. So it's 10.125.
Can you repeat that part?
So this distance from the base of the tube is
Mhm.
the tip of the fin to the base of the rocket.
Right.
This fins flush with bottom of fuselage? No, so there's like a gap.
Okay.
Oh, by how much? 0.125.
And that's the gap. Okay. 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 Gotcha.
So airfoil section. This is where RasAero is a lot better than Open Rocket because they have all these options. Ours is the hexagonal, which basically means if you look at it, like I have my mouse now, so a lot easier to control.
Nice.
But if you look at it from the top, you can kind of see it's like it's a very thin like hexagon. There's like a paper leading edge.
Yeah. Okay. Okay.
So this LE means leading edge diamond airfoil length. It's 0.533. And trailing edge, T is trailing edge, 0.225.
Hmm.
Gotta double check on the sheet. It's on the, yeah, point. And those are just like, if you're curious, because I did not know what that meant for a while, it's basically like this perpendicular distance is the leading edge. So like there to there, and then the trailing edge is like that distance.
Okay.
Also in the, all of this is also in the RasAero user's manual. If you're ever confused, it's pretty informative. So, okay. So press add. And so now we see we have almost the whole rocket. We need to add our boat tail though.
Mhm.
And the rear diameter. Rear is aft, 4.25. And the length is 2 inches. So now you have like what a rocket looks like basically. So very similar to RasAero, you have our center pressure, 81.8 inches. And at this point, I like to add the motor. So you go File, Import, or select Motor File. And then you'll have to browse to wherever you put that, probably in your downloads. And hit open.
Is that the RASP file we downloaded as well?
Yeah, so it should be like
Is the .eng file? Yeah.
yeah, .eng.
Right. Okay. Mm-hmm.
So options, you want to set the surface finish to smooth paint. Basically, we're going to paint the rocket, and the finish kind of affects like the surface drag and stuff, friction.
Right. Okay.
I will
Can I
add.
can I
Sorry, do you
ask
have a
what?
question?
Yeah. Sorry. Can I ask what type of paint? Is it metallic or?
That's actually a really funny question because we did use metallic paint one time and we had some tracking issues of the rocket. So usually it's not metallic.
Okay.
We haven't painted a rocket in a while, but yeah.
Okay. Okay.
So these launch site conditions, for me, they're just like I entered this previously and it just kind of saved that data. But the launch site elevation, you need to find out where you're launching and what that elevation is.
Mhm.
At Spaceport America, it's 4,595 feet. Honestly, I never mess with the temperature. It does affect like the barometric like stuff a bit, but it's
Okay.
kind of hard to like know that ahead of time.
Mm-hmm.
I also never add a wind speed, but you could. We try to launch when it's not windy, so ideally there's no wind. Like
Right.
morning, there's less wind, which is when we launch.
Mm-hmm.
And the launch rail. So the kind of standard launch rail that we use is provided by competition is 17 feet, and it's about 6 degrees from vertical. So
That would be the metallic rail that the rocket is mounted on, yeah?
yeah, that's
Okay.
kind of like as it's like building like energy, it like launches off that.
Okay. Okay.
So there's also all this kind of stuff that I never really like mess with too much. Like I don't I've messed with the recovery. It doesn't seem to really do much.
Mm.
Yeah, I haven't really played around with much of this stuff. Just use the flight simulation. So as it stands now, we don't have our flight data yet, but you can get these arrow plots. If you click arrow plots, you can plot your coefficient of drag, your center of pressure, just to like mock whatever based on your geometry. So if you ever want to see how the whole like overall drag changes, and you can go file, export to CSV. We use this data if in our ASTOS simulations. If we get there, I can show you.
In your what?
There's another software we use called ASTOS. We don't
Oh, right. Okay.
right now, but we hopefully should soon, and then we can kind of do a tutorial. So to actually run the trajectory simulation, you go flight simulation and double click on motors loaded. So sustainer motor is just like the motor. You can do multiple stages in this, so that's why boosters, but the sustainer is just like the main motor for us. We have one. So I'm gonna hit save. Okay, I gotta measure the weight. So in SolidWorks, you can easily just measure the weight, make sure there's nothing like suppressed, but if you just hit mass properties, it's 19 kilograms. And this is where we start running into conversions. So 41.8 pounds. So to edit the simulation, you got to double click on the motor. So loaded weight, 41.8. We got to measure the center of gravity and the nozzle exit. So, okay, the boat tail is hidden in this. Okay, so this blue thing's the boat tail. And this is the nozzle. You can see nozzle. So the exit diameter is this diameter here, which is 2.37 inches. Now to measure the center of gravity in SolidWorks, basically we already have our center of mass in here, but if you like assembly, reference geometry, if you don't have a center of mass, you can add one. I'll show you. Assembly, reference geometry, center of mass, and then it will just load. And so everything is measured, like the center of pressure and the center of gravity are measured from inches from the nose cone. So you'll also want to create like, this is a plane, you can see it's just like tangent to the nose cone tip. So if you select two things in the feature tree, nose cone tip, control click center of mass, evaluate, measure 73.8 inches. So center of gravity is ahead of the center of pressure, 71.8, 2.37. Save.
Did you say 2.37?
Yes. for the nozzle diameter. I'm just gonna, so if we just check our stability here, which is center of pressure, 81.8 minus center of gravity, which was what, like 73.8? I gotta measure that again.
Wasn't 71.8?
73.8, sorry.
73.8, sorry.
And then, so that's, and then you divide that by the rocket diameter and I get 1.7. So we're good. We're above 1.5. So we're stable. Let me make sure okay. See, I did enter the wrong thing. So I must have said 71. It is 73.
Okay.
So now to get your simulation data, you just right click on this, run selected. And this is kind of, it gives you like very preliminary stuff like your max altitude, your max velocity. There's this optimized weight thing, but I've never used this because we're pretty like constricted with weight. Like we kind of just need as much weight as we need. You can also have like multiple simulations, but you have to like if you want to simulate multiple motors, you can, but you have to like reload the motor every time.
Okay.
So to get your actual stuff, you like view data, and it brings up this guy. And as you can see, this bottom axis basically has everything that it gives you. So stage, just ignore that because it's not a stage rocket. Time, Mach number, angle of attack, center of, or coefficient of drag, coefficient of lift, thrust, weight, drag, lift, acceleration, vertical acceleration, horizontal acceleration. Same thing with velocity. The pitch altitude is like degrees from horizontal, altitude, and distance. And then you can go file, export to CSV. I usually do it every 0.01 seconds. And then we'll call it flight test 10K. And that's pretty much it. So then you can open up. So I saved it under my RasAero folder. So now you get this giant Excel document, which you can do with as you see fit. Makes it really easy to find like minimum and maximum because you can sort. So center of gravity, center of pressure, stability margin. So that's helpful. You can find like the maximum stability margin because it's not, the center of pressure just kind of fluctuates. So it's hard to actually find. But yeah, that's pretty much it for RasAero. Does anybody have any questions?
I would just like to say you made that look very easy. So thanks for that. Do you guys use all of this data, like from the Excel, for example?
Oh, usually not. The kind of the things we usually look for are, because we want to know like kind of the extreme conditions and then what also competition needs to know. So usually max speed, max acceleration, max height. And that's mostly it. Yeah, we don't,
Okay.
but we do make, and like maximum minimum stability. We will make like graphs of like trajectory or like altitude versus time and stuff. It's really good for making graphs for reports.
Right. Okay. And do any of the other subgroups use any of this data as well? Like the recovery or the payload guys?
A little bit. Like they'd be concerned about acceleration. Electronics are like sensitive to acceleration, or they can be, like they're only rated to certain things, so they need to know max acceleration.
Okay.
Other than that, aerostructure kind of uses, because they need to make their like fuselage and stuff strong enough, so they need to know the aero loads. But yeah, mostly it's just flight dynamics.
Okay. All right. One other question.
Any other questions?
I do have one more. That's okay. Hello?
Yeah,
Hello?
well,